Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I had actually explained about theorem 7.2 and also I have explained about theorem 7.3. And I have also solved example 4, 5 and 6. So in this particular video, we will look into the exercise questions which were there after example 6. So that is, in this video we will be looking into exercise 7.2. So we'll look into exercise 7.2. In that, coming into the first question in this particular exercise, here in an isosceles triangle ABC with AB is equal to BC, bisectors of B and C intersect each other at O. So that means here we have to draw one isosceles triangle ABC like this. So we have one isosceles triangle ABC. So that means AB will be equal to AC. And there is a angle bisector for angle B, and also there is an angle bisector for angle C, and these two angle bisectors are meeting at point O. So that is what they have given here. Join A to O. So that means here we have to join AO. So if this point is O, then we have to join AO. So now in this particular figure, you have to show that OB is equal to OC. So that is, this particular side should be equal to this particular side. That you have to prove. And you have to also prove AO bisects angle A. So that is, this particular angle and this particular angle, you have to prove they are equal to each other. First we will look into the first question. Here we need to prove OB is equal to OC. So we have to prove this. So now we will consider this particular triangle OBC. So consider triangle OBC. So in this triangle OBC, here, because here since triangle ABC is an isosceles triangle, since this particular OBC is an isosceles, in this particular triangle ABC is an isosceles triangle, angle ABC is equal to angle ACB. And in the data they have given that this particular BO is an angle bisector and also OC is an angle bisector. So in the place of ABC, I'll just write this in new slide. So ABC is equal to ACB, OCB, because here BO and CO are angle bisectors. So BO and CO are angle bisectors of B and C angle. So now this is nothing but OBC is equal to OCB. So that means here we are proving in this particular triangle OBC. So here in this particular triangle we are proving that this particular angle OBC is equal to this particular angle OCB. So if two angles are equal to each other in a particular triangle, means opposite sides should be equal to each other. That is, we have discussed in theorem 7.3. So in my previous video I have explained theorem 7.2 and theorem 7.3. So according to theorem 7.3, OC is equal to BO. So now, therefore, according to theorem 7.3, you can refer previous video for this. So according to theorem 7.3, OB is equal to OC. So this is what they have asked in the first question and we have proved that. So in second question, you have to consider this particular triangle AOB and this particular triangle AOC. So if we prove that these two triangles are congruent in this particular diagram, that is triangle AOB and triangle AOC, then we can easily prove that this particular angle BAO and OAC will be equal to each other. So in order to do that, first we have to prove these two triangles are congruent with each other. So consider, so here consider triangle AOB. So I'll just write this particular triangles in the new slide. So we have this particular triangle and this particular triangle. So we are considering these two triangles. One is AOC, the other is AOB. So consider triangle AOB and triangle AOC. Here AB is equal to AC. So here AB is equal to AC. That is because triangle ABC is an isosceles triangle. Now, since triangle ABC is an isosceles triangle, AB has become equal to AC. And we have proved that this particular OB is equal to OC just now. So OB is equal to OC. Before that, we will try to prove this particular angle ABO is equal to ACO. We know that angle ABC is equal to angle ACB. BO and CO are angle bisectors. So angle bisectors of angle B and angle C. So ABO is equal to ACO and BO is equal to OC. This we have proved in first question. So now this also we have proved. And we also know AB is equal to AC. So according to SAS postulate, or according to SAS axiom, here triangle ABO is congruent with triangle ACO. Since ABO and ACO are congruent with each other, therefore BAO will be equal to C. So BAO and OAC are equal to each other because these two triangles are congruent with each other. Therefore, AO is an angle bisector of angle A because BAO is equal to OAC. So that means that particular AO is exactly bisecting the angle A into two different halves. So this is the proof for second question. So now we have proved both first and second question in the first question. Now we will look into the second question in this particular exercise 7.2. In the second question, they have given one diagram. So here one triangle is there. So triangle ABC is there. And there is one perpendicular line for BC. That is, this particular angle will be 90 degree. And here D is there. So since BC is the straight line, here since BC is a straight line, and if this angle is getting equal to 90 degree, then this angle should also be equal to 90 degree because BC is a straight line. Straight line means total angle will be 180 degree. So if this angle becomes 90 degree, then this angle also become 90 degree. So these two angles are 90 degree. Now here they have given AD is perpendicular bisector of BC. And they have specifically mentioned AD is the bisector of BC. So that means this side and this side will be equal to each other. So now you have to prove that triangle ABC is an isosceles triangle. So here, based on the data which they have given, here let us consider the two triangles, triangle ABD and triangle ADC. Here they have already given ADB is equal to, or before writing the angle, let me write the side. BD is equal to DC, which they have already given because AD is perpendicular bisector. So AD is perpendicular bisector of BC. So since AD is perpendicular bisector of BC, here BD is equal to DC and BDA is equal to CDA. So for this also same explanation you can give. And here AD is equal to AD because those two are common side. So now according to SAS, so we are getting SAS axiom. So now according to SAS axiom, here triangle ABD is congruent with the triangle ADC. So therefore AB is equal to AC. Why AB is equal to AC? Because triangle ABD is congruent with triangle ADC. So that means here this side is getting equal to this side. So therefore in triangle ABC, AB is becoming equal to AC. So therefore triangle ABC is an isosceles triangle. So here they have asked to prove ABC is an isosceles triangle, and we have proved that triangle ABC is an isosceles triangle. So now we'll look into the third question. Here in the third question you have a particular triangle ABC. So you have a triangle ABC like this, and there is a perpendicular line drawn to this particular AB starting from C. This point is named as F, and there is one more perpendicular line drawn to AC where this point is named as E. So B is perpendicular to AC and CF is perpendicular to AB. So now based on this particular diagram you have to prove this CF is equal to B. So here we need to prove BE is equal to FC. So now in order to prove this, we will consider two triangles in this particular diagram. One is this particular triangle, that is AEB, and we will consider one more triangle, that is this particular triangle, which is AFC. So here A acts as the common angle for both of them, and this particular angle is 90 degree in both of these cases, because here the other side they have already given they are 90 degree. So since AB and AC are straight line, these two angles will also be 90 degree. That is, these two angles will also be equal to 90 degree. So now here AB is equal to AC. So we already got the solution for this. So in triangles, triangle ABE and triangle AFC, here we have to consider angle A is equal to angle A because this is a common angle. So angle A is equal to angle A because this acts as common angle, and here angle AEB is equal to angle AFC, which is already they have given, because they have given that this angle and this angle are 90 degree. So since AB and AC are straight line, the other side angle, that is this angle and this angle, should be equal to 90 degree. So now we know that AB is equal to AC because here ABC, triangle ABC is an isosceles triangle. So here triangle ABC is an isosceles triangle. Therefore AB is equal to AC. So according to AAS theorem, so that means here according to AAS theorem, triangle, this particular triangle AEB is congruent with triangle AFC. C. Since triangle AEB is congruent with triangle AFC, here BE is equal to FC. So BE is equal to FC. So that is the altitudes are getting equal to each other, which they have asked in this question, and we have proved that. Now we will look into the fourth question in this particular exercise. Here in fourth question, you have to consider the same diagram. So they have given the same diagram one more time. So here ABC is a triangle, and there is an altitude from C and from B like this, where this angle and this angle are equal to 90 degree. So here this is F, this is E. Now here you have to prove that two things they have asked to prove in this question. The first one is triangle ABE is congruent with triangle ACF. So the diagram is same, but here they have not mentioned AB is equal to AC because they have not given ABC as the isosceles triangle, but they have given that BE is equal to FC. So that means here they have already given BE is equal to FC, and in the previous question we had proved that AFC is equal to, that is this particular angle AFC and this particular angle AEB. So AFC is equal to AEB. So we are considering, so here we are considering triangle ABE and triangle ACF. So in that BE is equal to FC, which they have already given, and this is also more or less given because the other side they have given as 90 degree. So since AB and AC are straight line, this angle will also be equal to 90 degree. And here common angle is there, that is A. So common angle A is there equal to each other. So angle A is equal to angle A because angle A acts as common angle. So the diagram I have already written in the previous question, you can refer that. So here side, angle and angle. So that means according to angle side. So according to angle side theorem. So according to angle side theorem, here triangle ABE is congruent with triangle ACF. So that's it. This is the first question proof, and in second question you have to prove AB is equal to AC. Here since triangle AB, so here since triangle ABE is congruent with triangle ACF, therefore AB will be equal to AC. Therefore triangle ABC will be an isosceles triangle because AB is becoming equal to AC. So therefore triangle ABC is an isosceles triangle. So second question also we have proved in this particular fourth question. So this is all there in this particular video. The remaining questions which are there in exercise 7.2 I'll be teaching in my next video. So until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.